Let's talk now about another method for solving quadratics, which is the square root method. So for the square root method, the first thing you're going to want to do is you can only use this method, by the way, in two different kinds of problems. So notice in these set of problems here, there is no linear term. So if we can isolate x squared, how do we undo a square? What's the opposite of squaring? The square root. So if we can isolate the square, then we can take the square root of both sides, since we know that the square root of x squared, what is the square root of x squared? X. Okay? And using the square root property, so we said if x squared gives us a number b, let's say, then x will equal the positive or the negative square root of b. So essentially, let's say we know that x squared equals 25, for example. What would that mean that x would equal? Yeah, it actually could be, it could have been, the square root of 25 could have been plus or minus 5. Oops, I'm kind of messing that up. Plus or minus 5. Because if I take negative 5 and I square it, what do I get? I get positive 25. If I take 5 and I square it, I get also positive 25. So it's really important to remember this plus or minus right here, that we want all solutions. Mostly students forget the negative one, okay? And then we're going to solve the remaining equation for x. So let's look at two examples. So for the first one here, well, actually, we'll do all four of them. So for the first one, if I can get x squared by itself, it's kind of like solving a linear equation in a way. So how would I isolate x squared? What would I have to do to isolate x squared? Add 8. And you're like, but wait, it's set equal to 0. But that's because we're solving it a different way. And then what would you do to get x squared by itself now? Divide both sides by 2. Good. So we have x squared equals 4. So who can tell me what do you think x would equal? Plus or minus 2. We're taking the square root of both sides, and we get x equals positive and negative 2. Okay, so you could write it out in set notation, negative 2, positive 2. If I plug in each one at a time, we were talking about this idea of checking. So again, if I come back to my calculator, and if I plug in 2 times negative 2 squared, because I'm plugging in negative 2, that's one of my solutions. I have two solutions. Minus 8, what do I expect my answer to be when I press enter? 0, exactly. Okay, so that means I've checked the first one, and I'm just going to assume for now, I'm not going to check the second one, but I'm going to assume that it's correct. But you can always check it on your calculator. Okay, what should I do to solve? Let's do b together. What would you do here? Add 36 to both sides. You get 3x squared equals 36. And what should you do next? Yes, x squared equals 12. So what number times itself equals 12? It's not a perfect square, is it? But you can still take the square root of both sides. So we take the square root, we get, I'm just going up here, x equals plus or minus the square root of 12. Can we simplify? Notice it says right here, simplify your answers. I didn't read the directions. Use the square root method to solve. We got to simplify our answers. Is the square root of 12 simplified? No. How can you simplify it? X equals plus or minus 2 radical 3. Do you remember how we got that from before? Okay, that was in the last lesson, 7.2. Before this lesson. Okay, that's because 4 times 3, 4 is the perfect square, so 4 comes out as a 2. And again, we can check this. So if I plug this into my calculator, I'm going to go 3 times, let's do the positive, or I'll just do the negative one. Negative 2 times radical 3. I want to go outside of the radical, close that off, square it. I'm going to subtract 36. And when I press enter, what number do you expect me to get? 0. That's because it was originally set equal to 0. Now, those two problems are fine. You know, you have the x, you're isolating the x squared. Here, you don't really want to use the square root method. You don't want to FOIL this out and try and factor, because that's just going to be too much work. So what can we do? If we can isolate this square, we can also use the square root. So what should I do to isolate the square? Add 16 to both sides, right? I get x plus 3 squared equals 16. What can I do now to get rid of that square? Opposite of square is square root. I can undo the square using the square root. So I have x plus 3 equals what? Plus or minus 4. I'm so glad you remembered the plus and the minus. Now, if I go, this basically means I have two equations to solve. I have x plus 3 equals a positive 4, or x plus 3 equals a negative 4. So now when I solve that, I want to get x by itself. What am I going to do here to get x by itself? Yes, so I get x equals 1. What would I do to solve the second one? And I get x equals what? Negative 7. So my solutions are 1 and negative 7. And you can always plug those numbers in one at a time to check. Does anybody need me to show you the check, or you understand how to do that? Okay, good. All right, now what about this one? I want to solve for x. What should I do first? Add 18 to both sides. And you get x plus 2 squared equals 18. What should I do now to get x by itself? I want to solve. And why are we using the square root? X plus 2. The square root undoes the square. So we get x plus 2 equals plus or minus square root of 18. Does anybody know how square root of 18 simplifies? Square root of 18 is 9 times 2, right? 3 radical 2. So we have 3 radical 2 because we want to simplify it. So this was simplifying. And now what should I do to get x by itself? Last step. Subtract 2 from both sides. So I get x equals negative 2 plus or minus 3 times the square root of 2. And that's going to be my solution. Again, we can plug that in, or even we can find a decimal, round it off, and check that answer. But you can take that whole thing and plug it in. We could do it on paper too. I just don't have a lot of room there. Okay. Any questions on that? Yes? Why didn't we do that with which one? C? Because, oh, that's a really good question. That's because for C, 16 was a perfect square. So we could take the square root of 16. But 18 is not a perfect square, so that's where we were getting this idea of simplifying the radical. So just simplifying it. In fact, in the next section, we're going to learn about the quadratic formula. And in the quadratic formula, your answer is going to turn out like this if it's not factorable. And we'll talk about that in a moment.